All right, so today I'm just demonstrating several projects, and we'll see how it goes. And also, in case you care, I won't be using YouTube anymore because YouTube is vigorously telling me they're going to throw me off soon. So my videos on YouTube will probably vanish. Hopefully they will last until the end of the semester, but probably not after that. YouTube is going to throw me off because I have a podcast and we discuss serious COVID information, and they don't like that. So I'm moving to another platform called Dailymotion, which was the platform before YouTube. So you'll just find links here to the videos from now and not these thumbnails, and they'll be on Dailymotion, which will probably not throw me off. They're much less vigorous at throwing people off than YouTube, probably because they're less in the headlines and less involved in the politics. These are kernel debugging projects, and this is hacking LastPass, which is something I downloaded last week, which is pretty awesome. And I can demonstrate these with my typical Intel-based private cloud machine, but what I'd rather do is try them on my local machine. I just got working a day or two ago. There is a new platform, which I'm not sure I can find. Just a moment. I got to go to my news links to find out how I did it. There is a way to run Windows 11 on ARM now, and I found out how to do it, and I'm doing it. Windows on ARM, not that, it's not emulation. See, emulation would imitate the Intel processor. Right now I'm already in trouble. Okay, maybe Windows 11. How to run Windows 11 on M1 Mac for free. This is it. This is what I did. It's from April. And I'm going to put these link in the chat in case anybody cares about this. It does work, but you use this unusual virtualization software that I never heard of called UTM. That's what I couldn't remember. I don't know what it stands for, but UTM, this is UTM, and let me pin it to my taskbar before I lose it again. All right. And so I installed Windows 11. There are quite a few little gotchas involved, but I got it working, and I figured I'll try these Windows projects in Windows 11 and see how it works, because pretty much everything works in Windows 11, even though it's running on ARM. So we'll see how this turns out. And it might take a little while to boot up. Let me bring up the projects now that I've got my Windows. And I can always use a cloud machine, but I think it's more interesting to try it on the Windows 11 ARM machine and see how it compares. So the projects are 432, 3, and 4. That'll get us started. So 432. Okay. Kernel debugging with WinDbg preview. And they're still booting up here, right? Do I have to hit a button or something? Booted up before. Starting something. All right, I hope it's doing something. Just let me try the activity manager and see if it's showing any sign of doing anything. Oh, this is not moving. Oh, there we go. It's loading. Well, yeah, 458% in the QEMU launcher. Okay, so apparently this thing is QEMU, which is a common emulator, which is what you usually run on such a thing. All right, so it's loading at 591%. Okay, fine. The CPU is racing ahead trying to launch that thing, so that's typical for a virtual machine. So this thing will presumably cough up Windows 11 before too long. So let's talk about this. We're going to debug the kernel. Now the kernel is NTOS Kernel, a single file, NTOS Kernel.exe, and it's got to be loaded into RAM every time you're running. And someone says, is it possible to do the projects using Apple Memberlin with their ARM64? I have Windows 11 using Kernel. Well, some of them you can, and some of them you can't, but we're going to see. It's a good question, and I don't really know. So your user applications are here, like Ollie Debug and Microsoft Word and all that. And they then typically import the kernel 32 library. This is what Microsoft expects you to use. There are libraries that are intended for end users to use. This is called the normal API. They are the normal API functions that you use. And then there is the native API, which is NTDill. This is not expected for any developer to use. These are somewhat undocumented, lower level, more powerful functions that are harder to use, and programs are not expected to directly call ntdil. They're expected to call kernel 32, which is your doorway to ntdil. But malware often skips that and goes around to call the native API directly, which is a way to avoid some antivirus products and such. And then, but it's still not the kernel. This is all in user mode. But ntdil makes kernel calls into NTOS kernel, which is running in kernel mode. And then this talks to kernel data structures like drivers. So that's how it works. So we're going to look at NTOS kernel with CFF Explorer. Oh, good. It looks like this is eventually booting up. Taking a little longer than I expected, but it is moving. Move it up so you can see there. It's the little wheel is spinning around, so my Windows 11 will come. All right, so if you look at NTOS kernel, you'll see some functions it exports. And here's one, ALPC create security context. And I don't know what it is, but there's a lot of, I just want it there so we can see. Now we're going to use WinDbg preview, which will make it a little easier to debug the kernel. And aha, there's my glorious Windows 11. All right. And I got a normal local account, not a Microsoft Live account, which required changing the OOBE settings in the command prompt while installing it. But there's my glorious Windows 11. So the first thing I have to do is turn on debugging. So I should do that in administrator command prompt. If I right-click this, okay, and Azure Cloud Shell is right there. Well, that's new. Anyway, right-click this and run as administrator. All right. Let's see if the BCD edit works the same. I'm pretty sure it does. Windows 11, usually Microsoft does this. Usually the new version is the same as the old version under the hood, 90% of the time. It's the Microsoft developer preview. And you can get it by signing up for the Windows Insider program, which is free. I didn't know that. I tried it again a couple days ago. It's free. You just have to sign up for your Windows Insider, and then you can download this developer preview. So it's BCD, edit. Let's see what this looks like. Yep, that shows the boot partitions just like before. So BCD edit /debug on. Tells that I'm planning to debug this machine, and I can check it with DBG settings. Oh no, I think this is another part. Settings local. This tells me that I'm going to debug it from this same machine instead of having to debug it from another machine connected by a network cable or a serial cable. So now I got to restart it, which is right-click this button, shut down or sign out, restart. All right, and that may take a while, but anyway, after that, my machine will presumably be ready for kernel debugging, and in WinDbg preview, you can just attach to kernel right here, which is what I'm planning to do when my machine comes back. So let's see. Okay, there it is. And maybe it's going to have to spend what seemed like 2 or 3 minutes sitting there before it comes up. I guess we'll find out. Well, the mouse goes in there anyway, for what it's worth. All right. Anyway, so you can attach to the kernel on this machine. You do not need to run livekd the way we did before. It's the debugger can do it directly. I imagine all the debugger is doing is running livekd behind the scenes, but I don't really know exactly how it works. Now you can debug it locally here, and then it'll open up the debugger, and you can just issue commands to observe the kernel. So I'm going to give it a try.
Does the WinDbg come with Win11?
No, you have to put it on. You put on Windows debugging tools from the Windows 10 software development kit if you want the old WinDbg. If you want the new WinDbg preview, you'd have to go to the Microsoft Store, but the Microsoft Store is not available on Windows 11, so I had to go to a sort of third-party site that would let you download stuff from the store and bring it over. It was quite a chore. I might write it up as a project. For people, if you have an M1, getting Windows 11 running here involved quite a few little tricks and tweaks. One of the surprising things that happened is this virtualization product, by default, has no networking. So when you're installing the operating system, there's no networking. There won't be any networking until you get it installed and you install their version of VMware tools. But the problem is Windows 11 demands to have networking just to install it. They want you to sign with a live account. So I had to Google how to get around that. And what you do is press Alt F10 to get a system command prompt, and then you execute an OOBE/something command, which changes the out-of-box experience to give you the old out-of-box experience that lets you create an account with just a name and a password, which is no longer considered normal. So
is Win11 tied to your account?
Is it what? Oh, I don't know. No, I think it's very generic. There was no product key or anything. I think it's the same. Yeah. But it's easy, yeah.
You can put it on your website too.
I don't know. I'll probably just put instructions how to get it, because I don't really want to irritate Microsoft. But yeah, anyway, if this turns out to be useful, and I think it is useful, I managed to get a lot of things working on it, then I'll make a project so people with an M1 can try setting it up. But it remains to be seen how many of these projects will work out the same on here. When you actually get down to the assembly code, as we're going to see, it's very different, of course, this ARM assembly code. However, Microsoft just announced yesterday they're starting to sell Windows hardware with an ARM processor with Windows 10 for ARM on it. So Microsoft is apparently doing what's being threatened for years. They're moving to ARM away from Intel, which I would think everybody needs to do. The Apple M1 is so much better.
They have to.
Yeah, it's much faster, much lower power.
China is putting out PC on ARM.
Yes, and I think everybody needs to. So I think this is the future. So we might as well get used to doing ARM. All right, so now I'm in.
We even sold their x86 divisions.
Well, yeah.
The Intel CPU.
Who sold it? Intel?
Huawei sold
Huawei.
The Intel division, the
Well,
x86 division.
Well, good for them. He says Huawei sold their x86 division. Well, they're thinking right way. So let's run WinDbg preview. WinDbg preview. All right. And let's see how it works. Okay. There's WinDbg preview. So I can do file and attach to kernel and do it locally. Now I could connect by other things like USB or network, but I'm just going to do it locally. No debugger configuration is required for local server debugging, local kernel debugging. So click OK, and there you have it. I have to approve elevation to administrator, and the debugging session could not be started, failure. Local kernel debugging is disabled by default. You must run bcdedit debug on and reboot to enable it. Well, I think I just did. That's my feeling. I didn't put a minus, I put a slash, but I'm getting the feeling that this product does not work on Windows 11 on ARM. I think
When you run the debug on, it was saying successful.
it was saying successful. So I think this experiment with Windows 11 on kernel debugging has hit its stopping point. And apparently this product is not ready to do this yet. You could do it with live KD the way we did it last time perhaps, but it doesn't appear that kernel debugging is working here. So, all right, I'll go to my cloud machine after all.
Is that WinDbg work on Windows 10? You tried it before?
Yes, but I don't know about ARM. Yes, it works on Windows 10 and it works on Windows 11 on Intel. But I think it probably just isn't going to work on ARM. Anyway, all right. Well, that was worth a try. Let me go to my cloud machine where things will work. That's why a student was just asking me, can you use the ARM machine? And I said, well, I don't know. And apparently not so much. Which is the thing. All the stuff I'm using are previews, you know, betas, and Windows. That Windows debugger I was using was not even intended for Windows 11, so you know, you can't expect things to work too flawlessly. But you got to try and see what you can do. So I'll start my cloud machine and we'll do it there. I was thinking we'll need this anyway when we want to connect two of these machines together. So I only made one Windows 11 VM here, but I think I wouldn't be able to get much done anyway because the kernel debugging does not seem to work. They'll probably have to come up with a different version of the kernel of the debugger for the Windows 11 ARM kernel. All right.
You put the hotspot in the lab. There are a whole bunch of extra machines from here.
Well, this is running in my home.
But you don't have to, right now you're paying the electricity.
Right now I what?
You're paying the electricity.
Oh, well, sure, I'm paying the electricity, that's right. That's right. But I didn't have access to the lab for during the pandemic, so running it in my home was the only option. Yeah, normally I would avoid running things in my home because people could hack them and get in, but anyway, I'm Right now, nobody's using it but me, so it's not a big problem. At home, I really should set up a DMZ or something, but I haven't done that yet. All right, so let's see if this machine is ready to be debugged.
So the Win 10, right?
This is Windows 10. It's Windows 10 on Intel, so things should work as expected. So I'll go to Administrator Command Prompt, or so I imagine. There we are. All right. All right, and now bcdedit /debug on. And the other one was, oh, that's right, I'm in the browser already. It's here. It was bcdedit /dbg settings local. All right, and I'll restart this one. Yeah, it's worth a try. You never know. You know. So, besides, there might be a way around it. There might be some adjustment to these boot parameters or some adjustment to that debugger that can make it work. Since Microsoft is now selling machines with Windows 10 on ARM, then I think they're going to, and those are for development machines. Pretty soon, I guess they'll be selling machines with Windows 11 on ARM, and then they're going to need the debugger. So, if it doesn't exist now, it's going to have to exist before too much longer.
Huawei got a CPU 128 cores.
Yeah, that's what I mean. I think, Microsoft, America is picking a fight with China, and probably not at the wisest
The
times.
supercomputers are coming.
Oh yeah, and China's moving ahead in quantum computing and everything. Americans are freaking out, saying Chinese is a disturbingly strong competitor, and you could look at it that way. Yes, China is no slouch on this stuff, and we're busy fighting among ourselves. So we're not looking very good as a global competitor right now. We're spending all our time fighting among ourselves instead of making progress.
I think China is probably going to start a war with Taiwan.
That's true. That's the problem there. China's going to start a war with Taiwan. Both of us seem to have leaders that are nuts.
Getting all the power, so I think he will make a decision.
Yeah, he really seems. I don't know why he doesn't just have patience. They're gradually taking over Taiwan. If he just waits slowly.
There are a bunch of other reformers that hold him back. So right now he got all these people in, so he's gonna.
Yeah.
He's gonna one man show.
I know, but it seems like just like Putin.
Yeah,
There's no reason to do it. All you're doing is starting a big fight that you don't need to have.
There's no certainty of winning either.
What's that?
There's no certainty of winning.
Well, yeah. I don't know. I think there's. Yeah. Anyway, despite the point is, why do this? Especially, I thought China, you had a patient government. They could just gradually dominate a little more and a little without a big battle. They were on that path.
Because they were official, they were more like friendly to the U.S. So right now all those guys are out. So
Yeah. All right. Anyway, let's see if this works. Aha. All right. This is a start. This is where it crashed. And see, on Windows 10, it works on Intel. So now I'm into the kernel. All right. So now we can view loaded modules with LM. And there they are. This is the module NT with a symbols table. These other modules don't have symbols by default. NT is the kernel. NT is short for NTOS Kernel. I talked about it before. Now, because this is the GUI, such as it is, you can click the blue NT link. And then it executes a command, and it shows you some information about the NT kernel, like the starting and ending address and so on. All right. And you can click functions and go back to the start of the list. Here's the functions. And this is why I think this is ridiculous. It pretends to be a GUI, but then it does stuff like this. You click functions, and it gives you all the functions starting with A, of which there are thousands. So it doesn't really present it in a very usable way.
not like IDA Pro.
Right. It's not like IDA Pro, and not like Ollie Debug. I don't know why they didn't just leave it a command line product, because this GUI is just really getting in the way more than it's actually helping you. Yeah, it's weird. But anyway, now the start of the list is here, There. And so there it is, ALPC, something like that. So that one thing we were looking for was ALPC create security context. And there it is, ALPC create security context. So the same thing we saw by looking with CFF Explorer in NTOS Kernel, you see here. So it's just another view of the same thing. Now, we can find out what command was executed. All that GUI is doing is typing in commands, and there's what happens. When I clicked that link to see functions, it executed /d/f nt-bang a star. So it just looked, this examines functions in the NT module beginning with A, and I don't know what the /d is, probably add the address or something. So that's why they call it a GUI, but all it's doing is typing in the commands. And if you want to get any advanced things done, you just have to learn the commands anyway, so I don't know who they're fooling with this stuff. Anyway, so you can use help. There is a help now. On the home tab, on the right side, there is something called local help. And that opens the Windows Chum file, 3.1 help, which you used before, which in fact is where you get all those commands. This is the useful help that will tell you all those switches. So if you wanted to know what happened with that X command, it'll be here. X, examine symbols, there you go. And so if I double click that, there's examine symbols, and here where you can find out what all those command line switches are and stuff. You can learn how to construct those commands. So that's useful. All right, and then there's a flag defined, and then we can disassemble a function. So let's get rid of the help page and do UF. I know U is unassemble, and I'm not sure what the F is. Here, UF, NT-bang, NT, create, file. All right. And there we go, disassembling it. And you see the address, which is broken up into two 32-bit sections with an apostrophe in the middle, and then the raw hexadecimal bytes of the instruction, then the mnemonic, and then the parameters. So here you see XOR EAX to EAX to clear EAX, then move Q quad word, 64-bit word, from this register into that register plus a number. So almost everything moves from register to register, but you can move to memory and such. This is Intel 64-bit assembly code. So now we can search memory with this one, which is going to be search NT-bang, NT-create, file, and search for a distance of 100 for these pattern of bytes, 44, 24, 40, and the reason is because you can see it right up here. Here's 44, 44, 24, 44, 24, 70. Anyway, 44, 24, 40 is somewhere visible there. We're going to see it near the start. You're going to look for 0x44, 24, 40, there. And just to see how the search works, 0x40. There, I'm searching for that pattern of bytes. And there it found it. 44, 24, 40 is at this address, FF03, the address ending in 1103 or 11C. Oh, whoa. Okay, I was trying to zoom in and somehow whoa. Uh-oh. Misinterpreted something I did as a zoom command, and I don't know how to undo it. All right, view. Let's see if there's a zoom option or something. Not reset windows? That's no use. Right. Somehow it shrunk everything down. Home. If you ask me, that should be in view. Source, that's not a view. How about right-click down here? Yeah, this doesn't work. Well, I made some motion with the mouse that caused it to think I was shrinking things down, and now I can't do anything about it. Yeah, well, I will make one attempt to find it here, but I highly doubt there's going to be help anywhere that helps. WinDbg preview, zoom, yep, okay, I did something which it misunderstood and thought I wanted to shrink it down to 0. I think I just need to restart WinDbg preview as far as I can tell to get back to normal. All right, let's try it again. This is why I hate GUIs. I wish it was just a command line.
Is WinDbg open source?
Is WinDbg what?
Open source?
No. I don't think any of this stuff is open source. That might be nice too. Very few things Microsoft makes are open source. Just a few things, not that much.
Oh, this thing is Microsoft?
It's Microsoft. It's official Microsoft product, yeah. Yeah. So, all right, now I can sort of see it again. Now I want to do that command, which is search NTBang, NT create file, L100, 0x44, 0x24, 0x40. All right, now I was hoping to zoom in so I could see it. Okay, I can do it if I do it down here. If I do it up there, it will somehow decide to shrink everything down. So you see it going here. And what I wanted to do is compare these addresses. So let me get the previous one, which was UF NTBang create file, NTBang NT create file. All right, now if I can scroll back and compare these two, I can perhaps figure out what, there we are. That's what I wanted to do. Let's see if I can zoom in without this thing going insane on me. All right, so here I'm at 11E3, and it's a bit off the bottom here. So let's take 11E3 is where I found it. So I'll scroll down if I can figure out how to scroll down without anything awful happening. Okay, there we are. 11E3 is down here, 44, 24, 40. It's part of this command here. So that's all we did. We started searching at the start of this function and found that pattern of bytes there. So this is how you can find things from a hexadecimal byte. When I originally started using this product, I found there was a GUI Windows debugger, and I thought I would try to duplicate some of our OllyDbg projects. The first thing is always search for reference text strings, and there's nothing like that. The next thing is search for strings, but even that was hard, and I pretty much gave up. I could not reproduce the simple hacking projects we'd done with OllyDbg in this thing very well worth a damn. Although it can do it, and the old WinDbg can do it, but the only way to do it is to become an expert at those command line commands. And it's much harder. It doesn't have a lot of those handy conveniences, and I really missed them. So here we figured out how to search memory for binary. Now you can search for strings too. You can even search for all strings with S minus SA. We'll show you all the strings. S minus SA. It's not listening to me. S. Okay, minus SA. NTBang, NT create file for a length of 100. So I've limited the search to only go a certain distance to make it not take forever. And now it finds strings. And this is a little bit like bin text. So it's finding the printable strings. Nothing too exciting there, but you can search regions of memory for strings. All right. And so you can also go here. This is minus L6 in brackets. And these are strings of length 3 or more. That's the default. And you can make it search for strings of length 6 or more. So that is the previous command modified by minus bracket L6 before the SA, which is mighty unclear. Bracket, that's why you really have to read that help file to get any clue what these command line switches, because they're very far from obvious. And there it only has the one long string. So, all right. And so then you can display memory, display binary NT. This will show you the beginning of the NTOS kernel in a dump like you might see in Wireshark or any other binary tool with the address, the hex value, and here's this. And you can see it starts like every Windows executable with MZ and with the legacy DOS header, and below this will come the NTPE header and all that jazz. You can examine a data structure. Let's do DT, NTBang, and file object. All right, and now you can see the structure of a Windows file object. I guess I can shrink this lower pane down. I'm not using it. All right, and there should be permissions here. If I can get this thing to go up. All right. There we are. So there's a device, and here's read, write, and then delete. And read, write, shared read, write, and delete. You know, here's read and write, the main ones we talk about. These are the permissions. And each one of them appears to be 1 byte in size. For 9, for A, for B, for C. So this is the data structure And here's the file name itself is a Unicode string and so on. So you've got the structure of the C++ data structure that used to keep track of a file in the kernel. And of course, all this stuff is documented online. There's Microsoft pages telling you about these structures and what all the fields are. You can view processes with tlist, .tlist, for task list. And there you are, the running processes, some kind of Java updater, and Smart Screen, a security process, and somewhere in this mess will be the debugger we're using. So we can do process 00, LSASS, so bang process. I forget what the 00 is, you have to look at that chum file to find out. LSASS.exe. And there you get some information about that process, like the process environment block is, and the parent ID, I'm not sure what the C part is, and so on, some information about it. And you can open the process environment block by clicking the blue link, and now it dumps out the process environment block, which has, again, a lot of extremely detailed information. We've never dealt into anything at this level, but you can. Doing things like debugging device drivers. You can view devices and drivers with bang dev node, node 01 disk. And so now we get some information, I think, about the hard disk. So this is disk and vendor, Red Hat. So I guess whatever this, yeah, that's right. I think the Proxmox underneath my Windows Cloud machine is probably derived from Red Hat. I'm just guessing. But it thinks the disk is Red Hat. It's a virtual disk created by the virtualization software. Anyway, all right. And so when I did it on VMware, I got dev node. I got VMware instead of Red Hat there. So I guess that shows you the identifier of the virtual disk. All right. And then you can disable debugging if you want to. It doesn't really matter, but you might want to, and that's it. So that's what I wanted to show you. And as you see, on Windows 10, on Intel, it's okay. On ARM, not so much. So let me stop this one. If I can get over to the other screen, there we are. All right.